we will, for some reason, are you seeing the recording option up there?
Yes, it's recording.
It says recording. All right. Okay. I wasn't sure about the recording, whether it is on or off. So I have to, I think, well, I restart that process. So yes, just for the recording purpose, welcome again. And we are talking about software testing. And as I mentioned to you, that in software testing, we are specifically referring to the process of finding bugs in your program, trying to weed out the errors that exist in your program, and we look at various aspects of that. So we'll be covering up the topics of development testing, test-driven development, release testing, and user testing. These are certain aspects of testing, although testing is also normally categorized in different other forms. We will talk about that as well briefly. I think you already have heard about white box testing and black box testing. So we'll discuss that briefly as well. So as I said, it's a intent of finding errors before you deliver the software. And the intention is to deliver a high quality, error-free, bug-free software to the client. Mostly when you do certain testing, you create your testing data sets, or you create certain test data. These are also referred to as test cases. So it's basically tested using that test data, which obviously has to be very carefully planned in order to make sure that your tests are successful and you are able to make your testing effective. So this is basically what we do in testing. And as I said, testing can reveal the presence of errors, not their absence. So what does this line mean? This statement simply means that no matter whatever happens, you cannot achieve a situation, or a ideal situation rather, where you could say that, you know, my program is absent from errors. You can't make a claim like that. But yes, the endeavor is to reduce them and to make them as minimum as possible. So that is the basic idea of software testing. Software testing is a part of journal verification and validation process. Now, this is a very important term, and we call it as V and V model. So verification and validation, we'll try to look at it again, what exactly it means. And we'll discuss that in more thorough detail. So basically, the testing goals. What are our testing goals? It's basically to demonstrate to the developer and to the customer, when the developer tries to demonstrate to the customer that the software is devoid of any kind of bugs and it is meeting the requirements. So these are the goal of a software testing, and to see, analyze the behavior of the software, how the software behave in a certain conditions. And that could be, if you try to give a wrong input, how does the software behaves? And you are aware of that you do validation testing where, or you do rather input validations, where you are basically trying to test your program by providing different kind of wrong inputs to it. So, and you see that how your program handles that very well. Rather than crashing, it gives an error message, or it gives a notification to the user, tries to tell the user that they must enter this value into a particular format. If it is date, it should be entered into this format, long date, short date, whatever it is. If it is a telephone number, then it should be, marked with the extension. And if there is a specific format, you tell the user that they must enter data into this typical form. So you're testing the behavior, you are testing the inputs, and you are basically trying to create a software which stands the test of situations where the user is, trying to be as brutal or trying to be as much of a software breaker than the software user. So in any situation, if you get a user who's not very well trained or who deliberately tries to break into the system, your system can handle that situation. And your system, rather than crashing, can actually, try and uh, stay stable and try and make sure that it only accepts the valid input and also provide the correct output in any situation when it is being deployed. So as we say, software testing is also called defect testing. So we are trying to find out the defects in your system. And we are trying to see whether the system gives you the correct output. So any kind of incorrect computations or data corruption has to be avoided. So these are the goals. And if you look at testing, then you could say, yes, you have test data where you create certain test cases. You provide input causing anomalous behavior. So basically, you're trying to give an input in your test cases where you are deliberately giving it wrong data. So you are trying to provide wrong input and see how the system behaves. So you provide the right inputs and you see how the system behaves, and you provide the wrong data and you see how the system reacts to the wrong data. So, and finally, you analyze the output results. So it depends how intelligently and how strategically you have created your test cases and your test data that would reveal all different possible bugs that your system can can contain. So this is the goal of software testing. As I discussed earlier, the two main aspects that comes into software testing is called verification and validation. And of course, this will come back to this term. This essentially means that verification is a process where you're trying to see, are we building the product right? Which basically talks about the nuances or the details of your development process. So basically, you're trying to figure out different steps that you are doing towards building your software are, in the correct form, in the correct logic. Your procedures and functions that you have created are logically correct, and they are providing the right kind of outputs and right kind of behavior that your software needs. Moreover, basically you are looking at the detailed steps of software development and try to confirm that these steps are followed correctly. So it's more about getting into the details of the software and trying to make sure that you are following and you're doing the right thing at the right stage, at the right phase of your software development. So the software should conform to the specifications, definitely. Validation is a bigger picture. So while verification is more into details, into nuances of creating the software, your validation is a larger picture. So validation is, are you building the right product? That means, have you not gotten into deviating from the goals of your system development, which means that you are asked to create a, say for example, you were asked to create a hotel management system, right? And you don't eventually land up creating a hospital management system, which means broadly that you are still delivering the same product which was promised to the client. What happens normally is that, software developers also become very passionate about the development process, and with their imaginative, fertile minds, they are always thinking something new, and they're trying to implement something new. Now, in the process of doing it, they may, try to, put 100% or rather more than 100% towards making something very innovative. But sometimes in that exercise, they might rather deviate from the main goal, the main purpose for which the software was being built. So that is what is a risk, and validation is a process that is carried out from time to time In agile programming, it should be carried out in multiple iterations rather. In a waterfall model, validation is done only after I would say that your development phase is finished, the system is deployed, and then there is a testing phase, which we call it as a dedicated testing phase. Whereas in agile approach, your testing actually happens in every phase. So it starts right from the phase one of planning and requirement analysis and design and then implementation, and it goes, further into every single aspect of software development. So it's not limited to one phase only, which happens in waterfall model, that first you start planning, then you do design and then implementation, and then you do testing. So it's not like that, sequential approach that happens in a waterfall model. But in agile, obviously you have the rather intended effort to test at every single phase, and that also defines what you are testing and what is the strategy of testing at that stage. So I hope you understand the difference between verification and validation. Hello, guys, are you with me? Hello.
Yes, I think we understand.
Okay, why I'm getting such a delayed response? I think one of you could quickly unmute yourself and give me a quick response that yeah, we are with you, right? Okay, great. So that's a very important aspect, and I stressed upon it simply because of the same reason. So the aim of which is known as V and V confidence, basically. So the aim of V and V is to establish the confidence that the system is fit for the purpose. It is uh, quality wise consistent with the good programming practices of the technology that you are using. It is also consistent with the requirements that were laid down from the client when you are given the task of developing the system for that client. So basically, it depends on the system's purpose, user expectations, that means your client expectations, and the marketing environment. Also, what does the market demands, and in what situation, in what domain that software is going to be implemented. So that's basically what V&V confidence is all about. So software purpose obviously means that, how critical the software is to the organization. Basically, the organization will go for the software development only and only once they have realized that this software would increase the productivity of this organization and will bring about better management, a better experience to the customer, and a better performance for the team members of the organization. So these are some of the expectations and purpose of the software building, software development. So users may have low expectations of certain kind of software. So it is quite possible that user expectations can be varying from from different software to software. So there could be a software where there are very high expectations, or the software is supposed to be performing at a very high optimum level without any errors. And in certain situations, it could be that yes, it's fine even if you have some bugs. I don't think we all know that Windows operating system, one of the most popular operating system, and even other operating systems as well, do suffer from bugs, but we still buy them. The same goes with the various Office applications. Sometimes they hang, they misbehave, we all know that, but we still buy them simply because we know that all we have to do is sometimes kill the program, kill the process, and restart if they are hanging or they are not responding properly. So it's not a train smash, it's not a plane crash essentially. It is just sometimes closing the program and reopening the program and start working again. So we do that. So we have certain kind of expectations with certain kind of softwares. But imagine if you are sitting and you are into a flight, and the typical example is, of course, uh, those 737 Max planes. I'm sure you are aware of those tragedies where many planes crashed. Are you guys aware of that? The 737 Max Boeing tragedies that happened last year, when the whole fleet of 737 Boeing planes were grounded. Yeah, basically it was a autopilot error. If you guys are with me, of course you can I can hear some people quite busy in the kitchen. That's why I think your response is a bit delayed. Huh? Okay. So basically what we saw there was uh, certain software bugs in those systems, basically in their autopilot system. In the autopilot system, there were some sensors which were misbehaving and which actually resulted into those crashes where the sensors couldn't pick up the air pressure and the speed, all those things correctly. And as a result of that, it started to take a dive, like a steep dive down there. So it was a malfunction of certain sensors, uh, or rather a bug in the sensing software in autopilot systems. So that led to those accidents. So you can imagine that the expectations of softwares are different in different operating environments. So we cannot manage errors in certain life critical systems or systems which uh, can lead to accidents or loss of lives. So those kind of systems obviously uh, are very vigorously tested, very thoroughly tested, and should be, because it can put somebody's life into danger or in jeopardy. On the other hand, there are certain softwares obviously which have low expectation, as I gave example, that if one of your program crashes or one of your program stops responding, all you do is you restart that program. You don't really, call it a train smash. So that's what also depends on the operating environment. What is the challenge for software testing is today, every software development has a very strict deadlines. So basically you want to get the market early because you want to beat your competitors, or maybe if you're developing it for the client is sitting on your head all the time and pushing you hard to deliver on the deadline, to meet the deadline. And that makes it a very sort of a dire situation. How long should you test a program? How much testing is enough testing? And when you can call it, okay, we have done enough testing now we are ready for releasing the program. So these are some of the questions that we try to answer also when we are doing the validation testing. And there's a term which essentially we don't cover up in this chapter because this textbook doesn't talk about it. It's called cyclomatic complexity, which is basically one of the measures, one of the metrics to decide, how much testing a software is needed, where you're trying to figure out the critical paths, the critical execution paths of that software. And that eventually depends on, just to try give a little brief understanding about it, that depends on the number of decisions that you make in your software logic, in your program algorithm, and in your program writing eventually. So you can basically count the number of controls, the number of paths, different paths that your software can tread through while making a decision. Essentially, whenever you encounter a if then else construct, so you would look at how many different directions the software control flow can go. what different execution paths are possible, and that becomes one of the metrics. It's a complex formula, but you can Google more about cyclomatic complexity, and that cyclomatic complexity of a program determines how much complexity a program has and how much testing it basically requires, right? So yes, we have talked about this verification and validation. Uh, as I said, a very important aspect. And basically, again, we are revisiting to say that verification refers to uh, have the software implemented the specific functions correctly or not. Validation refers to the set of tasks that ensure that the software that is being built is traceable to the customer requirements, which means your validation is more about looking at the requirement list that is given to you by the customer and try to make sure that on a broader scale your software fulfills those requirements. So it's a bigger picture we are talking about in validation here. And in verification, we are talking about implementation and functionality and the best practices of performing the task and all those kind of things, right? So as I said, the first goal leads to validation testing. Uh, as we see that, you know, what exactly the system is supposed to perform and on a broader scale and how it is performing. Is it carrying out the functionality that was supposed to be there? Does it have all the functions that are listed in the requirement list in your requirement analysis or the document that you created when you were doing the requirement analysis, and the customer has given you a list of requirements. And obviously the second goal is the defect testing. Defect testing basically is to pick the bugs out and to weed out the bugs that you have. So the test cases are designed to expose the defects. So basically you will be designing the test cases, and the idea is to basically pull out those bugs from the system and fix them. Test cases, in the defect testing can be obscure, and they need not to reflect how the system is normally used, which means that you can test for certain extremes as well. You do expect system to be used in a certain way, but what if it is not used in that way? So that is one of the reasons why you have this approach, specified over here. So we've discussed this, and we said in defect testing, to discover the faults or defects in a software where its behavior is incorrect and in the conformance with the specification. So basically we are trying to discover the faults or defects that a system has. Essentially, that is part of our defect testing. So we say a test is successful if it makes the system perform incorrectly, so it exposes the defect of the system. So the job of the tester essentially is to basically try and catch that bug that exists in the system. And that is why when we are talking about testing, we are also talking about scenarios when the internal testing is a better option, and when you need an external testing team or a team of experts who are experienced testers, and that normally come out from the industry. Rather, they are not in-house people, they are not part of the development team. Sometimes they are not even part of the company, to make this testing process as neutral as possible. Because if you are testing your own code, then you would probably be very gentle on your software while testing. You would never really delve deep into it or try to break it down, because your reputation is at stake. Nobody tries to or rather enjoys being exposed or rather being termed as that, whatever you've done has some mistakes or some errors or some bugs. So obviously that ego programming exists in developers, and as a result of that, they may not really vigorously test their own systems because that would expose their own mistakes. And that is why we talk about external testing teams and all that, which makes a lot of sense for certain type of softwares. So a testing would basically try to show you the errors. It will make sure that it conforms to the requirement that you have made. Performance testing is also done to measure the performance of your software. And overall, the testing is an indication of quality. So basically, it's a quality benchmark that you're trying to achieve to say that my software is as error-free as possible and adheres to those conforms to those requirement of high quality standards. And that is why we have these CMM, SIE standards and different other quality standards in software engineering, because they are certain methodologies or frameworks that guide the software development process and that tries to implement a rigorous control regime, a rigorous quality control system to make sure that the software is thoroughly tested, the software is thoroughly correctly designed, and it conforms to the security guidelines, it conforms to the performance benchmarks and all those things. Okay, so to perform effective testing, you should conduct effective technical reviews, and in that cases many errors will be eliminated using before the testing commences. So there's something called they call technical reviews. Now these technical reviews basically are also part of the planning phase, because here you try to see before you have even begun developing the software or you have begun designing the system, you do certain technical reviews which would make sure that you have a plan in your hand, which if you follow correctly in a professional manner, you would land up in a software, you would land up with an artifact which is conforming to the requirements, which is conforming to the guidelines, and which performs in the right direction. So testing begins where you would say that you are talking about creating an artifact which basically performs in a ideal optimistic environment in the correct way. There are a few things. If you are basically following a component methodology, we're using the component model. So then at the component level, you have to look at whether the outward integration of your computer system, how your system would integrate with external components now. So that is one of the key factors you have to look at. And depending on type of software development that you're using and also the methodology that you are using in your software development, the testing techniques can differ. And basically, as we say that testing is done at different stages. Initial testing, which is called unit testing, which is done by the development team itself. So software developer will be doing the unit testing, and finally there may be a rigorous testing done by something called ITG, which is called independent testing group. These are the experts that are called from outside, and they are hired to do a very thorough, vigorous testing of your software before it is released to the customer. So certain big projects definitely follow that kind of planning, where they have obviously the internal testers, which is the development team, and they have the independent testing group hired from outside for doing the thorough testing of the system. So testing and debugging are two different activities. Now that is also very important to understand. Testing is identifying the bugs, not really fixing the bugs. It is very much possible that as a tester, your job is just to test the program and identify the bugs and report those bugs to the development team. And the job of the development team is now to fix those bugs. So as a tester, your job is not to fix the bugs. It's basically to expose the bugs and let the development team do the fixing of the bugs. So debugging is not uh, exactly you know, part of a testing strategy, but definitely it follows the testing process. So after the testing has been done, definitely those bugs have to be now rectified by the development team. So this is exactly what I mentioned to you. When a developer does the testing, which is obviously generally the unit testing or the integration testing as well, uh, they tend to test the system very gently. That is one thing, because they don't want to expose their own mistakes. They feel a bit embarrassed. They would definitely feel a bit embarrassed to expose their own mistakes. You know, it's a human nature. The other thing is also they're driven by the delivery. So basically they have their deadlines on their head, uh, and they are under pressure to deliver the software on the deadlines. So they cannot, and many times they do not do the thorough testing, because of these pressures, the whole effort is to finish the development process rather than trying to identify the bugs and trying to, you know, root out the bugs. So that's one of the challenges that happens. So an independent tester, on the other hand, is the guy, as I said, is a part of an ITG group, independent testing group, which is either a dedicated department in the organization itself, or it could be hired from outside. Maybe they are outsourced people. So in that case, you outsource your testing to the experts, and they do the thorough testing, which makes it neutral, unbiased, and obviously since they are experts, they know exactly where most of the time the bugs lie, where most of the time errors can happen, and they created their test cases because they have a vast experience of doing testing from years. So they are aware that what kind of errors normally happen in a certain kind of software, and they'll specifically do those kind of testing. So their testing strategy is, you know, built on the experience they have, being the experts in the field, and the type of software that you are building, and they bring these two things together to form you know, a very effective testing effort on the software. So there are a few disadvantages as well of bringing the outside people. As I said, the advantage is definitely that the developer will do gentle testing, where the independent tester will do a vigorous testing. That is one of the facts. A disadvantage is that the developer knows about the system functionality. So they are aware of the system functioning, what functions you got there, what interfaces you have there, and everything else. An independent tester has to learn these aspects. So first they have to learn about the system, and then they will try to, obviously, they'll try and attempt to break it. So the time also goes into learning about the system when an independent testing team is involved. So that becomes a disadvantage if the time is a very critical factor of delivery of the system. So we do see that at different life stages of life cycle, or different stages of software development life cycle, we see different testing strategies adopted, and that depends on the phase, or on the on the stage of the software development life cycle that you are presently in. So basically, when you are doing the coding, at that time you are doing the unit testing. So unit tests are done when you're writing a piece of code, a piece of program. As you write a small function, as you write maybe a class or a module, you immediately test it, you unit test it. So you provide some input and you see what outputs you are getting are and are they correct or not. Finally, once you have built various different components or you have built different modules or different classes, then you will put them together and you will do something called integration testing. So integration testing is, synonymous to your design modeling phase. So at that level, when you do design modeling, same time, obviously, you would be doing the integration testing as well. So you are modeling different components, you're putting them together, and you are doing the integration testing. Validation testing, as I said, basically is done at the analysis modeling phase. So at the analysis modeling phase, which means validation testing confirms whether you have basically adhere to the requirements, and that happens at the requirement analysis phase. So that's what happens at this stage. So overall, you do a system testing. System testing is more seen as a deployment testing, which is a bigger picture of your software, your system engineering process, where we talk about, a deployment when the system is deployed, right? And you do that testing at this point of stage. So essentially, these are some of the aspects of doing the testing. I think my screen is absolutely locked. I can't even see the time that has passed through. Anyway, let me pick the small alarm clock and keep it right there. All right, so you can unmute yourself and if you have any questions, just ask me. And I do plan to carry on forward. So when we talk about testing strategy, we talk about testing in a small, which means you do the unit testing first, and after that testing in the large, which means that you test the integrated components together. So testing a small unit, which as I explained to you could be a simple method or a module or a class. And further to integrate these components, these modules or these classes, and test the integrated artifact. So you start small and you go outside testing to the large side of it. There are a few other strategies also when we talk about integration testing we will talk about. So in a conventional software, one of the component is the initial focus, and then integration of the module happens after that. In object-oriented paradigm, when you say testing in small, you are basically talking about a class. So testing in small basically is a class now. In object-oriented approach, the smallest unit is the class. So testing a class that encompasses certain attributes. So obviously, the class is a blueprint which defines an entity and its attributes. So it consists of different attributes of that entity, and obviously it has the functionality or the behavior associated with it. So that is the unit of testing if you are using object-oriented approach. And further, you would look at the operations, or you would look at the integration of this class with other classes. So sometimes in component architecture, which is also as we were talking about, that day about service-oriented architecture, we were talking about that different components are remotely deployed. So that's how the software development normally happens today, where you have certain components working in one server lying in one location, and some part of the components or some set of components are on a different server in a different location, and now they communicate with each other remotely. So we are looking at a distributed programming architecture, which essentially is implemented by the SOA model or service-oriented architecture, where every software or piece of software becomes a service. So a software uses a set of APIs, and these APIs basically integrate and communicate with each other. So you are communicating or collaborating with other APIs remotely uh, in a different location, and that's how the software shares the functionality with each other. And that's what typically happens in today's software development scenario, where most of the softwares are basically in a distributed architecture, or they are implemented through service-oriented architecture, and they communicate through APIs. And these are typically known as, there are other different ways where the softwares can communicate with each other. There are different architectures there also. There is something called uh, in Java, this was known as RMI, remote method invocation. I think this was the mother of these architectures, where you could remotely invoke a method. So your computer or your server sitting at one location can actually trigger another method residing on a different location. And there was an architecture that was developed for that. This was known as, I hate that sometimes, when this happens anyway, which was known as Corba. So Corba was an architecture which was called Common Object Request Broker Architecture. These were the platforms on which today's service-oriented architecture has been built, and it has reached a very high level of sophistication, of course, where today every piece of software more and more is defined as a service and remotely used uh, and remotely called, and the data is shared and communication happens through something called a set of APIs known as REST APIs. Now this is a totally web-based architecture where a service is deployed on a particular server, and it sends its calls to other APIs through protocols like SOAP, simple object application protocols, through SOAP envelopes, and it passes on its data to others. And there's a lot of communication and collaboration. You can take a screenshot of that if you want, because I'll move to the next slide. So basically here, that's what happens. A lot of communication and collaboration happens in today's software development process. So as we see, we have to adopt a strategy which is very much in line with our software development model, the way the software will function, the way it will be operated, and so on. So these are some of the issues which we have to look at. Other strategic issues basically means that you have to, of course, look at your requirements in a quantifiable manner. That means you have to have a very clear list of your requirements before you start testing. Because as we see, we said the validation is one of the key of your testing process. So validation means at every stage you would validate that you are still heading in the right direction towards building the right software. So that is basically the goal essentially. So it has to be done in that way. State testing objectives explicitly, which means that you have to have a clear written document of written documentation of your test cases. What are you going to test? And you follow that guideline specifically. You have to keep the users of the software in your mind when you are designing your software testing strategy. And you have to develop a profile, which is also called use case testing, of course. So you have to see who will be the actors, the use cases, and accordingly you have to strategize your testing strategy. In today's agile approach, most of the time when agile approach is being used rather than the traditional waterfall, you have to have rapid cycle testing, whether you're using agile approach or you're using your extreme programming or you're using the Scrum approach. All these approaches basically demand you to have a rapid cycle testing, which means there will be various iterations of these tests done quite frequently. Build a robust software to design to test itself. Now, what does that mean? While this testing seems to be, appearing as a very a tedious exercise, there are certain platforms and there are certain frameworks which you can use to automate your testing. So whenever you do any change in the software, these testing environments or these testing tools, as you can call them in a simple way, can actually run some automated test on your software to see that after making those changes, your software still remains functional in the desired form. So this repetitive testing normally is known as regression testing. Whenever you make a change, you have to do a testing to make sure that the software hasn't really developed a bug because of those updates or those changes that were done. So regression testing is done, and this regression testing can be automated. So technical reviews, these are done prior to testing. That means technical reviews are basically like a pre-plan. It's considered to be a preemptive task of planning while you are starting to develop a software. And we'll talk about something called test-driven testing, where the tests are already created before you start developing the software. So you start by creating and defining your test cases, and then only you create a class or you create a component and then you test it. So the first testing is obviously, as you say, without even writing a piece of code. So that is a test-driven development. We'll talk about that. But essentially, that also helps to make a robust software where you will be developing a software which will be devoid of any errors, because you will be testing it at every stage, and you have already laid down the strategy and a pre-plan how the testing will go about it. So technical reviews are done to assess the testing strategy and develop the test cases. And a continuous improvement approach for testing the process is always developed. So essentially, you have a list of modules that need to be tested. You have test cases, a list of test cases that you have created to test those modules. And then you have the software engineer or the software development team member to run unit tests and give you the results out there. So this is the process of unit testing. And unit testing is basically done at different stages of software development, and of course the developer or the software engineer is involved in creating these test cases and doing the unit testing. So this is the first form of pragmatic testing that you implement in your software development process. So what do you test at the unit testing stage? You would test interface. In a graphical user interface, in a GUI environment, you can easily identify interfaces as user interfaces. It's easy to, identify them and envision them. But in certain cases, these interfaces are actually the functions that help you to communicate between two components or two classes. So an interface could be actually in a component-based architecture or in even an object-oriented other environments. It could be actually the entity, or it could be a function which helps you to communicate between two different entities. So you have entity A and you have entity B, and you have an interface between them that allows you to communicate from entity A to entity B, or a component A to component B. So this interface could be a special function or a special mechanism which sometimes needs to be tested. So in a distributed environment, as I said, interface could be specific functionality, protocol, or could be a call, a function call to another entity, another component lying in a different location. So that is to be tested apart from your basic interface, which you normally see in a standalone applications. Local data structures are tested, and most of the time the boundary conditions are to be tested. Now this is very, very important. Your boundary conditions normally are most vulnerable areas where you have the bugs and the errors that happen. That means that you created a loop that was supposed to run from 0 to 10, uh, and then you have an array which is basically being read or being written to while you're running this loop, and the array size is also 10, which means that your loop will execute 11th time as well. 0 to 10 obviously means 11 iterations, whereas your array only has 10 uh, 10 indexes, or only 10 elements stored in it. So you would encounter a out of index array exception. Obviously, these are the kind of errors which happen quite normally, quite frequently, and that is why the boundary condition testing is so important. Independent paths, I did mention about cyclomatic complexity. That CC, cyclomatic complexity, you can Google about it. You would try to see what different execution paths your software has, although we won't go into detail of that here, but what different independent paths the software execution can have. And that could be one of the deciding criteria to figure out how many test cases are enough and have you done enough testing or not. Error handling paths, of course, you do your redirects or you do your exception handling where you say if this error occurs, then your control should go either it will display a message, that wrong input, uh, or the input format is wrong or the value is wrong, whatever it is, or it could redirect the user to a different probably interface or a different uh, in a different redirect them to a different page if we are talking about a web interface where the user can restart the process of data entry. So your error handling paths, how they work, how effectively they are working, is the user being redirected in the right direction, in the right location, on the right page. These are some of the aspects that we have to be clear about the unit testing process. So your test cases have to be designed accordingly, uh, keeping these aspects in mind. Interface, local data structures, boundary conditions, independent paths, and error handling paths. So that's very important. Uh, in a unit testing environment, basically, obviously, as you can see that sometime what happens, you're developing a module and this module needs input from outside. It takes input from an external entity from outside. So in that case, you have to either wait for that another team that is working on that other module. Say, for example, this is your module 2. We call it M2. And they are working on another module called M1, which is still not completed yet. And they're still functioning on it. And you want to test your module. So either you wait, and time is the most critical factor these days, or what you can do is you can create a driver module, or we sometimes call it as a driver class. So you create a driver class. Driver class is a simple dummy class which is created just to give the input to your module. So if your input module needs two values, X and Y, in a specific format, which is calculated in a complex way, say for example, and then it is being supplied to this module, and it takes these parameters into account while doing further processing or further calculations. then you can simply supply two dummy or examples of these X and Y values, which are more appropriate to your functionality. Of course, you can change them to test different scenarios, how it will perform if it gets the right values, how it will perform if it gets the null values, null or zeros, how it will perform if it gets the wrong values, the incorrect values. So all these are part of the testing. So then X and Y would be given to your module to do the testing. The other thing is your module will give an output. So if your module is giving an output, this output has to go to a set of other functions or set of other components which have to deal with it, but they are not ready. So what do? You can create stubs. Now stubs could be simple, like a simple web page. So if you have this condition or you have done this and you have a certain output coming out of your program, and that output obviously means that you are supposed to be directed to a page, a complex web page. Say for example, you are developing the shopping cart. So in shopping cart, you have developed a module to add all the items to the shopping cart. You are adding it to the shopping cart, right? Now you want to see that from there you should be heading towards the invoice section, the billing module, which calculates the total, subtotal, and the tax, and provide you a full calculation of your invoice. And this is not ready. So what would you do? You would create a stub. A stub would be just a dummy page, say for example, or a dummy function or a dummy class that would be invoked. And this is just to test that your module is working perfectly, or your module is working in a correct manner. So you can create stubs and drivers. Drivers are basically which gives input to your module, and stubs are basically those dummy classes which serve as output module or as an output controller of your module, where the output goes down to them. So these stubs are basically used as the dummy as the dummy classes, or you can just to imagine it correctly, you can call them as dummy pages, web pages, where you could say, you can create just a dummy static page to display, that your controls and your flow of your program is working in correct manner. So if you get a certain input, you are to be redirected into one side. If you get a different kind of input, then you are to be redirected to a different location, or a different class would be invoked. So these stubs will help you to test whether that control is working perfectly or not. So this is what happens. And once you start doing integration testing, these drivers and these stubs are replaced by original modules or original classes. So they will be eventually replaced by the original module and original classes while doing integration testing. So in integration testing, you will be putting or replacing them with the original modules. So what happens in integration testing, as you normally see it as a big bang approach, which means that you are putting up the pieces together like a puzzle. So this is your module M2 you are working with. This has to fit with M1, and probably this has to pass on some value to M3. So basically we are looking at putting these pieces of puzzles together, and obviously there will be some vertical integration like in this example, and there will be some horizontal integration like the modules which run parallel to your modules, and they run in a parallel manner to your modules. So there are different strategies and different approaches of integration testing. One is called the top-down integration. Now top-down integration means basically you start from the top and you start replacing all the modules in the depth. So you would say, okay, let me finish one full process. Let me complete one full process and let me test first. So it would start with A and then go to B and then C and downward. So this is the vertical or top-down integration, where top module is tested with stubs. So basically you have this one and here you have a stub. and you have another stub, and you have another stub. So stubs are replaced with the real modules in depth first testing. So you replace one set of stubs, in one leg. You just try to complete one leg of flow and see if that works perfectly fine or not, without going into other branches of it. So as you can see, as new modules are integrated, some subsets of tests are is to be rerun. Obviously, regression testing, which is called regression testing, so regression testing has to be done whenever you add a new module or you replace a stub with a new class. So this regression testing will be done every time. In bottom-up integration, obviously, the drivers are replaced one at a time. So basically, what you do is you also create a cluster of lower modules, and then you integrate them with a driver class. So basically, what are you doing? Drivers are replaced one at a time in bottom-up approach. So you start from the bottom and you head towards upwards. So obviously you will be putting these together, and what you look towards is now a driver class, basically, which is first created as a driver class, maybe like a dummy class, but eventually replaced by the real class when it is fully developed. So this is what happens in a bottom-up integration approach. In sandwich testing, if you are too much into a hurry, then you use probably a sandwich approach. So what happens, like one of you can answer me, if you really want to meet somebody very quickly, you want to meet them now, what is the best strategy? And I think the interest is on both sides. You are interested to meet someone and the other one is also interested to meet you. So what do you do? What do you do? I mean, your friend lives in PMB and you live in Durban. So what do you do? What would be the quickest way to meet quickly?
Meet
as quickly
halfway.
as meet halfway, exactly. So sandwich testing is about meeting halfway, and thanks for the answer. Also tells me that you're still awake, huh? All right, so in sandwich testing, this is what happens. You start by putting stubs or replacing stubs in a top-down approach, and also you start the bottom-up approach at the same time and meet somewhere in halfway. So these clusters are put together, and then eventually these clusters are linked up with the driver classes, eventually replaced with the original classes, and that is how you do your sandwich testing, while you are also starting from the top to bottom, by replacing the stubs with the original classes. So that's what happens. Great. Regression testing, we discussed that, okay, regression testing, I mentioned about it, and I said regression testing is re-execution of some subset of tests that have already been conducted to ensure that the changes have not propagated any unidentified side effects. Basically, what we are doing in regression testing is nothing but whenever you have made an update or any change, you are quite likely to introduce an error, or maybe as a possibility that the system will misbehave in some way because some code has changed. So to be sure that that change hasn't made or created a bug that has affected your software adversely, you would do something called regression testing. Now in regression testing, basically the whole set of test is not repeated. Only a subtask or a subsection of that test is normally repeated, which is specifically attached with that section of your software which has been done. Mostly regression testing is done in automated fashion. So whenever there are changes, automatically a regression test is invoked, and it is conducted to see that the software overall is still functioning correctly. So whenever there is a change in the software, regression testing would be executed either manually or in an automated manner to ensure that the software hasn't become buggy. So it helps to ensure that the changes do not introduce unintended behavior. That's basically the idea behind it. So it's basically either done manually by re-executing a subset of all test cases or using automated capture playback tools. So there are certain tools. We'll talk about a tool called Selenium, which is used for web testing. We'll also discuss that in briefly, when we are talking about testing tools. Smoke testing is another term which basically conforms to daily builds. So typically in an extreme programming environment or in an agile approach, you do your sprints, and then when you do your sprints, you also do your daily builds. And after doing that daily builds, of course, you do something called smoke testing. So basically you're testing your daily builds every single day to ensure that your software is when you put all these pieces together, you do the integration testing, you can be quite sure that after integration testing your software artifact will be still functioning in the right direction. So normally in smoke testing, what happens is the software components that you have coded up are integrated into a build, which includes data files, libraries, reusable modules, other components, and they are all tested together. So what you are trying to do is, it's also as the ironically the phrase goes, that you're trying to fly the plane as you are building it, which obviously cannot happen in a real world environment. You can't fly the plane where you haven't attached both the wings to it, or you haven't attached the engines to it. But in a simulated environment, you can do things where you can fly the prototype or a semi-completed prototype also, just to see how different parameters behave and how it works. So without attaching the engines, you can fly a simulated version of it. So basically, it's more like creating a basic infrastructure, or rather basic test structure, I would call it, with the data files, with the library files, even though your software is not complete. But you're testing like a semi-finished plane to see whether it will fly properly or not. Because obviously here you can add certain components to it as test classes and see if it performs in the intended way or not. So these are some of those environments, and some of these testing frameworks provide you these kind of environments. They provide you the libraries, they provide you the data files, like dummy data files, data sets, through which you can do the testing. So the main key is the smoke testing is done daily. That is the key. Obviously, these are done in association with certain support architecture or support framework that you need to run your program, which is provided by the test environment. These certain test environments provide you that. And a series of tests are designated to expose the errors that will keep the build from doing the right function in the right time, right? So the intention is to uncover a major error which becomes a showstopper for you. So basically we're trying to say, although still there could be still some bugs sitting there in the software, but it doesn't become that change doesn't become a disaster for you. That is what you're trying to prevent. So after making that change, where it could be just like improving your font, improving some formatting in your software reports, or in your output of some data that your software is doing, and you see all of a sudden your software has stopped working. So you don't want to land up into that situation where that change becomes a disaster. So smoke testing can prevent that. So your build is integrated with other builds eventually, and smoke tested daily. If the other builds are not completed, then you can have those as I said, driver classes and stub classes, which will help you to test your application in a like a you can call it as a simulated environment, just to understand the meaning of it. Although it could not exactly be the simulation that you do in real time. So the integration approach may be top down or bottom up when you are doing the smoke testing. Okay. Uh, the person who was saying that the person has to attend to an interview can obviously excuse themselves if you're running out of time. I think we can still continue till 1 o'clock. So we still have some time. Uh, Guys, do you need a break or can I continue?
I think it's fine, so you can continue.
Great. So we talked about inspection, and inspection, as I said, is more about it's more considered to be like a technical review does form part of an inspection. It is more about analysis of a static system. It's also called as a static verification. So static verification means you're trying to look at you're trying to analyze your code in terms of the best practices. Every technology or every programming technology that you're using have best practice standards. So you're trying to figure out whether the developer is following is using the best practice standards or not. So that's one of the things that you would look at where you would do your inspections, or you call it as a static verification. At times this is also called static testing. Testing as as in a classical terminology is also differentiated as static testing and dynamic testing. Now, static testing is you are testing your code. You're testing how the code is written. You're testing or rather verifying whether there are any errors in the code, any kind of logical errors you can see, you can spot, and other kind of errors that you can visually see in the code that no, this code is wrong and this has to be changed, this has to be modified. So that is part of your static testing. And of course, it is also referred to as white box testing because you are trying to look at the code and trying to find the errors in the code itself. So as you can see, when you try to compare, there are certain terminologies which might be slightly, relabeled or slightly changed. Like here, they're calling it as static verification. But essentially, this is nothing but static testing and dynamic testing. So if we sometimes it helps her to stick to the classical, the classical approach because it makes you understand the concept better. So that's my point. Although you may pick up another set of book which might refer to a different name, which happens quite a lot. Every organization may have their own terminologies that they are in love with and they really use them quite often, which normally happens. But in a programming world, in a classical testing domain, we definitely refer to these as static testing and dynamic testing. We refer to them as white box testing and black box testing. White box testing means you are testing the code or the program. Black box testing, which is again dynamic testing, which means you are running the program and testing it. And essentially your black box testing would be done by an external tester, not really the development team itself, because now you are testing it like a user would use it, or a hacker or a cracker would break it, if they get their hands on your software. So the testing will be done in a different scenario. So when you're trying to see how the software operates in terms of functionality, not in terms of details and the coding and the the structures that have been used, the arrays that have been used, or the loops, or the various methods, or various decision structures. No, they don't get into those details. They would test on the functionality itself, and that is the point here. So software testing, as we say, is with exercising and what you would call it as a product behavior, which means you're testing the functionality of the software, which is again your dynamic verification, or we call it as a dynamic testing. So just to make it simple, you could say this is my static testing, uh, and this is my dynamic testing, right? This is my white box testing, WT, and this is my black box testing. We call it as BT, right? So this is basically what we are talking about. So dynamic testing is black box testing, and static testing is basically white box testing. I hope I'm clear on that. As I said, okay, sometimes as they would differentiate between the term inspection and testing, which slightly differs only in terms of the process and nothing more than that. So inspection is more of part of the validation process. So this is part of the validation process, where inspections would see whether the requirement specifications are being met, the software architecture is conforming to the requirements, your UML design models, that means your logical models, are also consistent with the requirements that you have made, that you have committed to the client. Your database schemas, which obviously could be your, depending on your ERDs now, right? Which depend on your ERDs, are also in the line. And finally, your program that you have created is also adhering to the same norms. And you do the testing, and then you basically create the system prototype. So your system prototype should adhere to the requirement specification. Plus, when you are creating and you're programming it, you would also check all these other parameters that we have listed here. So inspection becomes a more of a bigger exercise, as I said, at every stage of your software development lifecycle. So in a agile approach, where you will be doing multiple iterations and you will going through these phases, these stages multiple times, this becomes critical that you have to test them at every stage to see that there are no anomalies between your requirements and your design and your coding, your implementation of your code. So this is what you would be doing, the testing process there. So in software inspections is just a broader term given to all these steps. What is being checked? So the aim is to discover the anomalies. Inspection may not require execution of the system. So it could be done before implementation, which is more about checking your requirements, your logical design diagrams, your UML diagrams, checking the configuration data and test data and all that. So it could also be examining your test cases also before even you have started coding itself. So it has been seen that this has been quite effective for discovering any major errors in your program. So advantages of inspections. Okay. Inspection, as I said, is a more of a validation process. So it is a holistic process. Inspection is a holistic process, which means During testing, errors can mask other errors. That means your testing sometimes, if you are doing unit testing, you are very confined to a smaller area. But maybe when you are doing the inspection, you are going across different stages of artifacts. You may be able to pick up some issues there. So in your own little world where you might be thinking that you are creating your piece of artifact, your own piece of software component, in a fantastic way, only to realize that when you want to fit it with another component, it doesn't fit well. And this was a classic case of study. I think again, was it from Boeing, one of those airline companies, where they obviously built a plane and they built those parts of the plane in different countries in their different centers. Probably one was built in France, the other was built in Germany, and some was built in some other country. And when they brought it together, just to find that there were some errors in the design itself, and the electricity conducts or the electricity conduits were not fitting together. So that means one piece wouldn't really fit together with another piece, and you can't run wires from one point to another point. So that's a typical example to say that inspection would try to eradicate and try to avoid that situation, because you have a full overview of what is happening in the software development. So incomplete version of a system can be inspected without additional costs. If a program is incomplete, then you need to develop specialized test harnesses to test that part that are available. Again, we are talking about those drivers and the stubs. So we are creating those drivers and the stubs to test your system, because other parts are not fully complete and ready. So searching for program defects and inspection can also consider broader quality attributes of the program, such as compliance and standards. As I said, inspection is more of a validation process. It's a holistic process. So it's a holistic process, and I think that's one of the reasons that it has to be in that way. I think I do have a milestone 1 presentation as well, if I can recall that. So maybe I have to end it, maybe after a couple of slides. So inspection and testing are complementary and not opposing to each other. So that's the point they are making. Both should be used in a V&V process. As I said, inspection is more of a validation process, whereas testing is more of a verification process. So inspections can check conformance with the specification, but not conformance with the customer's real requirements. Now what happens is, also in today's world, you are aware that the customer's requirement also keep on changing. So here you are looking at the requirements list, and that is how you're doing inspections. So if the requirements of the customer has changed, the real requirement of the customer has changed, means that it is not in the list. So the customer needs something different or something to be changed, but it's not in the requirements list that was given to you at that point of time, last month, say for example. So inspection may not really conform to that. So you again have to have, and that is why in agile programming, the customer meeting is a very regular phenomena, and you are always motivated to, and you are always rather, advised to interact with the customer, because what if the customer requirement has changed in due course of doing the system work. So that is what one of the facts. So inspection cannot check a non-functional characteristics such as performance and usability. So yeah, you can't test these parameters of performance and the other parameter of usability as well in inspection, because the system is not ready yet. You don't really know how would it perform, how good it would perform, or how bad it would perform. But yeah, you are broadly trying to avoid any kind of design errors. you are broadly trying to avoid any kind of those errors which essentially can be prevented at this stage. So still unless you have shared the prototype with the user and let the user use the prototype and give you feedback, it may be very difficult to really figure out the usability aspect and the performance aspect, which obviously can only be done when you are deploying the system once you have finished the programming of it. So in a software testing process, obviously you design the test cases and you prepare the test data, and then you run the program with the test data, and then you have the test results and you compare the test results with the test cases. So this is the overall design of testing process, and then you create your test reports. So basically that's what you are trying to achieve in your testing model. So when we talk about and we have already mentioned them, stages of testing. So we have different stages of testing depending on different stage of software development life cycle. So you got your development testing, which happens during the development when you're trying to find the bugs and defects. Release testing, where normally in release testing you do the black box testing, where the testing team that tests the software is basically probably an outsider, like ITG we mentioned about, independent testing group, right? So they will be testing the separate independent team will be testing your release. That's what happens before you are deploying the software, but the software is complete now in your own terms, unless you find a bug and you have to go back to the you're designing your drawing board to fix it, as we call it. User testing obviously is where the potential users of the system test the system. So essentially we can also call this, now we will obviously come to that, we'll come to something called alpha testing and beta testing here. But essentially your development testing could be just your white box testing, right? Whereas your release testing will be your black box testing. And then user testing is further a black box testing, but we can further categorize this into alpha testing and beta testing, right? So you can call it as an alpha test or a beta test. So we'll discuss about alpha and beta tests further, and then we'll discuss about all these things further as well. So I think few things will be just repeated because these concepts would come and again, and we'll go through that. So in development testing, basically what else we do is we test all the activities, testing activities. So development testing can further be split up into unit testing. We discussed about it. Component testing, where we are testing a component, and the system testing. So these are three stages of development testing. Unit testing, you are testing a unit, which could be a function or a class. You're testing the functionality of the object, or it could be just a method of that object. Component testing, where several individual units are integrated to create a composite component. So this is basically an artifact which functions on its own. A component's definition is a self-functioning, although in today's world there's nothing like isolated island. Most of the components are interacting with outside components and they work in tandem with remote components, as we talked about system-oriented architecture. But what essentially happens is that component testing does do a sort of a testing a full artifact in its own terms, and it should focus on testing component interfaces. So basically you are testing that component interfaces, whether they function correctly or not in their own sense. System testing obviously is a wide testing of the system. So all the components that you have created after doing the integration testing, they are all integrated rather, and they are tested as a whole. So your system testing is basically after integrating the components, and you can also call system testing as a, a, a major activity of integration testing, because you have integrated various components now together, and now you are seeing how they perform together in that environment. So integration testing is basically a form of a system testing, right? So I think we'll end at that. We'll describe about unit testing and other these things later on. I believe I need to check. So we are at unit testing, slide 35. I'll escape this with the team. Yeah.
I think I wanted to clarify about the section that will be removed for the test, called the system distribution. I can't really find that section, but the chapters that we have discussed before was software evolution, security engineering. So I was wondering if it was in security engineering, because I did see something with distribution in that chapter.
I think the topics that we have covered so far, just a second. Okay, we have covered evolution, we have covered security, right? And we are covering this software testing now, right? So essentially, yeah, I think the plan we had also had distributed computing as listed onto it. We may have had a few hints of that here and there, and I think when we are talking about certain aspects of software engineering, and I do bring in a few concepts which I find relevant, and I talk about them in that context, because they make some sense to understand the present context itself. But essentially we haven't I'm not basically planning to cover up distributed programming, distributed software engineering as such. So what was the question again? Sorry, I don't know if I have got you correctly there.
So I just want to clarify, is it a section in one of the previous chapters that we are leaving out for the test, or is it a chapter of what we were discussing, like chapter 9, chapter 13, or is a portion of one of those chapters?
Basically, no. Distributed software engineering was supposed to be a chapter on its own. So it's not a component, it's going to be a chapter. It was supposed to be a chapter, but I'm just thinking that we'll only cover up chapter 9, chapter 13, and this one, which is, I think, what is it, chapter 8 in your prescribed textbook. I have, though, inserted a few slides from Pressman there, just to get a bit of a clarity about software testing, So I did introduce a few slides from Pressman as well, which is basically the classical authority on software testing. So these are all new guys there, the new writers coming up. And in one way, they are relevant in terms that they are bringing some new fresh aspect in today's software development environment. But sometimes they try to confuse the fundamental concepts themselves. I found that they don't mention it that way. So sometimes that is why I try to refer to these concepts in a more classical way to make that understanding as far as the domain of software testing is concerned. How do these current terms, which they are redefining now, fit or align with the basic terms. So distributed, I can put the slides up for the knowledge sake. I'll put the slides up. You can read through them, but I may not be covering them up into the tests. All right.
Thank you, sir. Understand.
So that's it basically, because I think, from my side and from your side, I don't want to increase the scope too much. So basically we are focusing up on these 3 chapters as far as the test is concerned, that probably we are writing on 3rd of August. So yeah, so you have, I hope, diarized that date, 3rd of August, and yeah, and we will be covering up these contents there. All right. Okay, thank you. Thank you very much. Thanks for joining in.
So what time on the 3rd of August? Because generally in the mornings we have a lecture with Dr. Prabhakar on the 3rd of August, generally in the morning.